So my name is Fauci. I work at Twitter on the Android app. And today I'm going to be talking a little bit about some work we did to improve how we serialize data on the Android app at Twitter. I'll go through a little bit of why we decided this was a project we should take on, what we actually did, what changes we made, and then what the result was, what improvements we saw. And finally talk a little bit about the project itself because we open sourced it, so it's now available for use by other people. So hopefully what I talk about today you find useful and you might consider incorporating it into your apps. So to start, I'm going to talk about why did we do this? Why did we decide we wanted to take on this project? So how many of you guys use Twitter? Great, a lot of you. So you're probably familiar with this experience. Basically, you open the app, you have a bunch of tweets, you're scrolling through pretty fast, kind of not paying attention. You want things to load pretty quickly. And so like the timeline performance is something that we have paid a lot of attention to for something we want, a place we could improve within the app. So a couple of years ago, we were noticing it was pretty slow, and we were looking into what we could do to improve it. And we found out that whopping 15% of the UI thread time was being spent on data serialization and deserialization in the database. So talk a little bit about what exactly that means. Basically, if you look at the dynamics of a tweet, here's one from droidCon. It seems pretty simple, like there's some text, there's some media here, a user, URL. You'd think maybe not too bad, but our tweet object looks something a little bit like this, so huge. And if you think about this as, okay, so we're storing a tweet in a table. Say it's a table called tweet. Each of these fields could be a column. So that's fine for simple values like booleans and longs, but a lot of these fields are complex objects. So you see we have a bunch of these, tweet content, promoted content, all this stuff. So each of these, in order to store in a column, you'd have to package it up into a blob, a byte array. So this is kind of the part that was taking a lot of time, putting this in the database and reading this field out. In addition to the performance, it's also a bit of an issue for a developer to have these complex fields serialized because you can't really make changes to them. So anytime you change a field of like tweet content, you suddenly break the structure of the serialized data. And usually it leads to really weird errors that you have no idea how to fix. And even if you do know, you end up having to wipe the database. Gets super frustrating. You want to throw your computer off the desk, which definitely been in this place before. So we were kind of looking at how we could improve these things for both the user and the developer. So to go through a little bit, kind of what we were looking to fix, like I said, performance was kind of the main motivation at first. How could we improve the performance of the app? Then backwards compatibility, debuggability, so from the user perspective, how could we make it easier to make changes to our objects, easier to iterate? We have a lot of developers working on our code base, so how could we improve that process? And then flexibility was, we didn't want something that required a huge overhaul of our code base. We had done a lot of work to kind of modularize things, move them into models, and so we wanted something we could use within our app. So just for kind of context, most of you are probably familiar with the existing Android libraries. So there's serializable, externalizable, parcelable. These are interfaces that you can implement and it allows you to package data. So these are kind of what we were using as the baseline. And so kind of looking at these four pillars, performance in all of these is not very good. That's mostly because basically for, especially the first two, it's taking information about the class and packaging that up into this byte array. So it would put the class name, the package, and what this does is so when you go deserialize it, you know the code knows where to look for how to create the object. But that lookup time is really where this performance gets slow because it has to read this class and then find it. And that takes a lot of time. So we were thinking about how we could kind of remove that part. Parcelable is a little bit faster, but it's not, you can't really use it in the database. It doesn't have the same guarantees. So backwards compatibility, debuggability, there's not a lot of support. Externalizable, you can have optional fields, but like I said, a lot of the class information is being packaged into the byte arrays. So if you even change the class name, I know there's been a lot of talks in the past 2 days about how to like modularize your app. Anytime you moved a class to a different package or anything, you'd break the serialization because that information was packaged up into this byte array. And then lastly, flexibility. One nice thing about all of these is they're pretty flexible. So you could implement serializable on any class you have. You don't really have to do a ton to make it work. There's a couple requirements with the constructors and stuff, but for the most part, pretty easy to adopt. Then additionally, we looked at a couple more custom serialization frameworks because other people were trying to solve similar issues as we were. Two that we looked at were cryo and flat buffer. So for cryo, this basically is has these serializers which allow you to define more explicitly how you're serializing data, which you'll see is similar to kind of what we ended up with, which is pretty performant. For backwards compatibility, they have this system of annotations where you could have versions. It does slow down performance a little bit because there's some lookups there. And mostly the debuggability, there wasn't really any addition there that we found. And flexibility, this was kind of the main thing. It uses bytecode generation, and for Android, we need DEX. So didn't quite meet all of our use cases, even though it was still kind of doing similar things. Flat buffer as well. It was performant and backwards compatible, very efficient, probably more efficient than a lot of them. But part of the reason it was so efficient is because you're structuring all your model objects to use this schema that these flat buffers use. So basically, what that means is in order to use it, you have to rewrite or kind of incorporate it into all of your models. And like I said, we had done a lot of work to kind of build out our models the way we wanted them to be. We didn't really want to be rewriting them again. So looking at these these are kind of like what we're trying to accomplish with these changes. So now I'm going to go into a little bit about what we actually did. So we created this framework called Serial, the pun with the cereal. We liked the name Serial too, but this was a little bit clearer. So basically, if we look at a model object like the tweet, so I'm going to use a much simpler version of the tweet than what I showed you at the beginning because that's way too many fields. Here we have some simple fields. We got an ID. We have some object fields like a user. That's the author. We have a list of hashtags. Pretty straightforward, though. So how we want to serialize this object is to define what's called a serializer. You can see at the bottom here, we created this object serializer of a tweet. And what it does, it allows us to define how to serialize and deserialize that object in these two methods, serialize object and deserialize object. So what those methods actually look like, if you see at the top, serialize object, you are getting an output stream, basically, to write to the byte array, and the tweet object itself. And what you do is you take each field and you write it on to this output. And then the deserialize object, you take this input stream, which is from your byte array, and you read each field. So for simple fields like long, pretty straightforward, you write and read long, just like you would kind of on anything else, like externalizable. For the objects, you are using serializers as well. So for the user object, you have a serializer defined just like this tweet serializer, and this would tell you how exactly we want to serialize the user object itself. So we have writing and reading here, using that same serializer. String, simple like the long. And then the list of hashtags, we added a bunch of utility methods, basically, that allowed you to take things like lists, maps, sets of any object you have, and serialize them without adding a lot of extra work for you. So you can just pass in the object serializer, in this case, the hashtag, and then use this collection serializer to do the whole list. Finally, in the deserialize object method, we're turning the tweet object. So we are saying exactly what construction we want to use, what fields we're adding in. And so, as I mentioned earlier, a lot of the kind of expensive parts of serializable and externalizable was this lookup, basically saying, okay, we know we want to build a tweet because we read that from the byte array. We have to find where the tweet is, which constructor, how to add them, and that takes a lot of time. So we were kind of taking all of that out and saying we're going to explicitly say this in this deserialized object method. Here's how we want to create the tweet object. And each of these fields are exactly defined how we want to write and read them. In addition, so as you saw with that serializer, we aren't using really any state. We're getting, for the serialized object, we're getting the output stream and the tweet, and we can just write each field, and then we're getting the input stream, and we can just read it out. So we created basically static instances of the serializer in the class to make it so, as you saw with the user, for example, if you ever want to use one of these serializer within another serializer or serialize into the database, you can just use this static instance. So finally, if you're now deciding how to serialize this into a column, you use this object serial, and basically you can just instantiate it. It handles all of the actual byte stream optimizations and stuff for you. Go into what that looks like in a second. But there's two methods on it, toByteArray and fromByteArray. And basically what you do is pass in the object in the serializer, gives you back a byte array, and then you can, to deserialize it, you pass back in the byte array and same serializer. So pretty straightforward once you have the serializer defined to actually package this data using this new framework. So if you're a developer using this is like pretty much what you need to know, that you have the serial object, you can call to and from byte array on it. But for the purposes of this talk, to explain to you why this actually works, I'm going to go into a little bit of detail of what the streams actually look like. So for the structure of the stream, basically we have two kind of types. There's the simple types like long, string, Boolean, and that is the top here. You basically have a type header, which just indicates that it is a long or that it is a Boolean, and then the value itself. And then for objects, we also have headers, just says it's the start of the object. Then we have all of the fields, so that could be simple ones like the type header and value at the top, or other objects, so kind of nested within this object. And then you have an object end that just delineates that that's the end of the serialized object. So for the tweet example that I showed, this is kind of what the stream would look like. It starts with an object start for the tweet. You have the ID field with the header value, the author object, so you have a start and end with all the fields, the string header value, and then since list is just an object, you have a list object start, all the list items. So in this case, they would be objects that also have start and ends, they're hashtags, and then the end of the list. So it's very well structured. You can see it has like very clear markings of where this object starts and ends, what each field was, what each field is within it, but not a lot of information beyond that about the tweet. So there's no, it doesn't say anything that this is a tweet object, it doesn't say the package, there's no extra information. So we're really trying to kind of pare down exactly what's needed to serialize this. And because we've explicitly defined it in the serializer, we don't have to add any of this metadata. So what this really comes in handy for is when we're trying to now make changes to this object. So for, say we're trying to add a new field. We added this Boolean, its favorite, and we are updating the serializer. So we have write Boolean, read Boolean, seems pretty straightforward. So as you might realize, this is going to break serialization because we now added this new field in, and if the tweet, as it was before without this field, is already serialized in our database, when we go to read this field, we're going to get an error that looks something like this. Now, I don't know about you guys, but this means nothing to me. It basically tells me there's something wrong with my tweet, something about data. I'm not really sure how to interpret this to get anything meaningful. So you end up being really frustrated, and just wiping the database basically defeats the purpose of storing it in the first place. So to fix this, we decided to make a much clearer error message. So this is what it looks like now if you get an error. There's a couple parts here that I'll go through. So to start, at the top, you have a serialization exception. So what this says is you expected a value of type Boolean and found a value of start object. So it gives you a little bit of information of, okay, there's a field that we hit that we weren't sure, or that was not supposed to be there. But the second part is really where you can get the most use out of it. So because we had that very well-structured byte stream that had all these headers and starts and ends, we are able to kind of dump the stream out and allow you to look at exactly what was found in your database. So what this second part does is say you have the tweet as the outer object, and then it shows each field that was in there. So you have the ID, the author, text, and then lastly, the list of hashtags. The three little arrows next to the list are indicating that this is the point in the stream where we had the issue. So this would all be in like your logcat if you were looking at the error. And so you can now use this all together and say, okay, it's telling me that we expected a Boolean, we found a start object at this exact point. If you go back and look at the tweet, you say, okay, this is where I added my is favorite field. I must have messed something up. This is where the issue is. So this is great, but not that useful if you don't actually have a way to fix it. This is just showing you exactly in the stream where that would be happening. And using that object start header to indicate that we did not find a type header for a Boolean, we found an object start header. So now to fix it. Backwards compatibility, we added support in this library because that was really important to us to be able to iterate on these objects. And how we did this was adding versions. So to up the version of your serializer, you just add a version in the constructor. So in here, we are upping from the baseline, which is 0, to 1. And what this does is it stores a version in the object header. So now in our serialized tweets, we have some tweets that are version 0, the ones at the top, and some that are version 1. And what we can then do is we would read from, when we deserialize this tweet, we would read from this header and figure out what version we're looking at. And then in deserialize object, use the version number to actually decide what to do about that field. So if you see at the bottom here, if the version is greater than 0, so from version 1 onward, assuming we want to keep that field around, we are going to read the Boolean because it's now part of the tweet object. But before that, in version 0, when we didn't have that field, we don't want to read it because it's not there. So we put some sane default, in this case, false would make sense. And that can now allow us to have both versions of the tweet in the database without wiping anything. As you can see in the stream, yeah, it's this point in the byte stream that we are looking at where we have to decide whether we want to read it, and we, in version 1, do, in version 0, don't. So one question that I have gotten before on this is, okay, so you're adding these version numbers, but doesn't it get really out of hand? It's a very fair point. So we have a couple of things that have helped with that. One is just trying to keep track of where you have versions in the app. So say we have a lot of migrations in our database. At some point, we just kind of wipe everything anyway and start over with the schema. And that's a good time to kind of reset the version to 0 because you no longer have old versions in there. It's kind of hard to keep track of. And in some cases, like for our app, like the draft database, we don't want to wipe users' drafts because that's really annoying for them if you have stuff saved. So what we did was added something called a builder serializer. So we had spent some time adding builders to our objects. As you might have, if you think about that first tweet that I showed you that was 2 columns long of fields, a lot of times you don't want to have a giant constructor where you have to add all the fields. So we use builders, maybe some of you do as well. And so we could kind of use this to our advantage in these serializers. So as you can see with the builder serializer, instead of deserialize object, we have deserialize to builder. And now we get this builder passed in. And in this case, we would basically now read each field and set it on the builder. So when we're adding this new field, what we can do is just add it to the end. And then we have this code inside builder serializer. inside the serial framework that basically says if you hit the end of your serialized object, or you hit a field towards the end if you hit a field at the end that you don't recognize, so in this case, if it was trying to read the Boolean and we realize we don't have a Boolean to read, it would throw something like an optional data exception. As a developer, you don't really have to worry about what exactly it throws. But basically, as you can see at the bottom, we just ignore that exception. And the reason we can do this is because we are basically saying we want to build the object as is without this extra field. Because in the case where we're deserializing this old object, the field doesn't exist. So we want some kind of default. If it's a required field, that's where you would need probably to change, like you would need some sort of default that would work, or end up having to wipe the database. But in the case where you can kind of add these fields iteratively and you would be setting a default anyway, this is a good way to avoid version numbers. So yeah, as you can see, you don't have to even up the version here. You can kind of use this builder serializer framework to do it for you. And so this has been really useful for us because you can add 10 more fields on here and all the versions can be existing in your database. So instead of throwing your computer off, you can do a happy dance. I don't know who this person is, but they seem very happy at their computers. So cool. So I want to talk a little bit about what this actually accomplished. So I had showed you kind of those 4 things at the beginning: performance, backwards compatibility, debuggability, flexibility. Let's see how we actually did. So to start, we can look at performance. So we took an object in our code base called tweet entities, which is within a tweet and basically encapsulates all the stuff that's not text within a tweet body. So that would be media, URLs, hashtags, all that other stuff. So it can get pretty big. And it was externalizable before. We ran a bunch of round-trip serialization, deserialization on it just to kind of see what the average was for timing. And before, it took about 4.5 milliseconds for both serialization and deserialization. So that's about 9 milliseconds round trip. And the stream size was about 2,300. So once we used this serial framework, it was less than a millisecond for serialization, less than 2 for deserialization, and less than 3 for round trip. If you're curious why deserialization is more than serialization in this case, the time it takes to create that tweet at the end of deserialized object is just a costly operation to some extent. You're creating a new object, so that's kind of where that's coming from. And the stream size is down to 500. So if you look at the gains for this object, it's about 3 times faster to serialize round trip, and almost 5 times smaller in terms of the actual memory that we're using to store this. So it's pretty good. We thought pretty good improvement for thinking about like the time that it was actually just taking to package up this data and read it out. 3 times faster and 5 times smaller felt pretty good. As I talked about, backwards compatibility and debuggability. So the version numbers were allowing us to iterate on these objects and make changes and keep them all in the database without wiping them. Builder serializer as well can add these additional fields if you add these additional fields at the end. One important thing that I mentioned a little bit earlier was that it no longer relies on class name or structure. So anytime you wanted to move a class before, that would break serialization. You'd have to wipe your database. Now you can move everything around wherever you want as long as the serializer stays the same. And you can access that serializer. You can just call it, and everything should happen exactly as it did. And for debuggability, these error messages that I showed you are a lot more detailed. They allow you to kind of see exactly where things might go wrong and actually look at the stream itself, which we found really useful. As just a personal anecdote, had a ton of crashes on something a little while ago, and I had no idea where to start. Able to repro it, looked in the log, had one of those error messages, saw exactly where in the object the issue was. It was like a different object that someone else had changed, that their versioning didn't work or they forgot to version. I was able to like find that issue and then fix it with a versioning rather than wiping the database because I would have had to cherry pick that, and that can get really messy. So this has really helped us, especially with a big team, on all these iterations and making it so that we can make these changes a little more seamlessly. let's see. Flexibility. As I mentioned, we were looking for something that was a non-invasive approach. We didn't want to rewrite our whole app just to make serialization faster. We wanted a way to add it onto our existing models. So this is what this allowed us to do. We can layer it on top of classes. These serializer classes are their own class. You can even add them for imported classes, or so say you're using a different library and you want to serialize that object into your database, you can write a serializer for it. Android classes, anything that you have that previously it would be hard to make it serializable, you can include it in these. For using it, the serializers, like I said, are stateless, and we have these static instances. So instead of worrying about carrying through context or anything, you can just call user.serializer, tweet.serializer. Very simple. Last thing to talk about, you might have noticed when we were defining serializers, they're pretty verbose. It's kind of on par with like parsable or externalizable before, where you were kind of defining everything. So definitely not ideal, but that's kind of, as I mentioned, part of like what makes it so efficient. We have this really explicitly written out. So we did a couple things, some on our team, kind of as just a side project to make this better. So we started with an Android Studio template, so you could just type OS for object serializer or BS for builder serializer, and that would just kind of put out the skeleton for the serializer, put out the static instance for you, which is nice, but then you still had to write all the fields. So then same guy decided to write a plugin for IntelliJ that basically auto-generated the serializer for you, given the fields. So we're hoping to kind of add that actually to the open source at some point, because it's been really useful for us to avoid the time of just kind of writing it out. So if you're looking at this table, you're kind of able to make gains on all of these 4 things that I mentioned that we were looking to improve on. And we've been using this in our code base for, I think, almost 2 years now. It's been like over a year and a half. And it's been really, really useful for us. And like both from a developer perspective and from the user, just in terms of our work and trying to make that more performant. In addition to just using it for serializing into the database, we were able to actually use it as a foundation for a bunch of other changes in our code base. So firstly, we used it to kind of wrap intents and bundles. So if you're, rather than defining things as parsable and serializable and all these things, you can kind of use a serializer anytime you want to package this information, pass it around. Additionally, we did some changes to our database where if you define a database column with an object and you have a serializer for it, it can automate the serialization into that column. LRU caching, if you want to cache some value, you have a serialize for it, you can package it up and use it, put it into the cache. And then for activities, if you're trying to save state for orientation changes or anytime you need to save state for when you recreate the activity, again, you're able to use the serializer to package up more complex objects than you might have otherwise been able to. And we've added some work on this that uses annotations to even do some of that for you. So these are all things that we're actually looking now to see if we can open source as well, because they, like I said, have been really useful for us. Having this serial library as the foundation, we were able to make a lot of improvements elsewhere in the app. So hoping that other people will be able to benefit from that as well. So here is the information about open source. We have it at github.com/Twitter/serial. There's more Twitter open source projects at twitter.github.io. We are about to publish a blog post on Twitter OSS, which is the official Twitter account for our open source at Twitter. And so within the serial library on GitHub, we have some documentation. Should be some similar information, but a little bit more detail about how to use it. And just a big thanks to the team. We've had a lot of people across our Twitter for Android team working on making this happen and making this open source so that you guys can all use it. And that's pretty much it for me. But I'd love to take questions if you guys have any. Hopefully I didn't go through that too quickly.
Thank you very much. That was super interesting. One thing I'm wondering is, why you decided to serialize and deserialize things from byte arrays as opposed to mapping it into SQL databases or something like that.
So I think part of this was basically the like specific use case that we started with was like we have these tables already, we have columns that we were trying to fill with blobs, and we had these things defined as serializable. And so like how could we just make a change for these classes to switch something over without kind of overhauling everything we had with our database? I'm not going to say this is like necessarily the perfect solution for everyone. For us, it was really useful because it was allowed us to make kind of iterative changes. We had, I think there's some stuff still in the documentation if you look at the open source about how we kind of basically were able to take classes that were serializable, define these serializers, and kind of use proxies to make it so we weren't breaking everything while we were making these changes because there were tons of people writing new features. We were not trying to make them all stop so we could make 2 changes. But it's possible that there's ways to make it using other kind of structures.
Hi. So how about the case for objects with inheritance? Would you essentially like have a base serializer and then you have the child classes extend that serializer? Would that be the right approach?
Yeah, so this has actually been a really interesting thing for us as well. We do have, like I mentioned, we have some utility methods like collection serializers. We do have an idea of a base class serializer, which basically there's kind of 2 parts to this, I guess. In one case, yeah, we have base serializers that then you can inherit to or use as a base for your serializer of the like superclass or subclass, I guess. We found some issues with that, basically around the version numbers. So if you're using a version on the like subclass, and then the superclass had a different version, passing through the version had some issues. So the best way to kind of avoid that we found was to try to make everything have its serializer and then call that concrete serializer. So instead of doing super.serialize object and passing it in, you would say use the concrete serializer for the superclass. I think there might be documentation for this in the open source because you look confused and I feel like I'm not explaining this super well. But basically this was another pain point I should have mentioned earlier. Just kind of making sure that these versioning between the superclass and the subclass were consistent and not causing issues with what we were having. So what I mentioned with the base serializer concept is say you have like class A as your superclass and then B and C inherit from it, and you are serializing an instance of B as A. We basically can define, don't know what happened, a serializer that is a base class serializer that says we're gonna include serializers for all the subclasses, and then the serializer will be able to determine, you basically use as kind of a numbering to say, oh, this is like an instance of C, so we're going to read it as C but have it as A, which hopefully was not super confusing. But yeah, we have some support for it if you're doing it if you're trying to serialize as the superclass.
Thanks for the great talk. I had a quick question. So the one advantage of using something like JSON or flat buffers is that your server side also speaks the same language, so you don't pay the cost of converting from JSON to maybe an intermediate format and then to your Java objects. How does this work with that? I mean, like with your backend, and was there any cost to converting the stream to whatever your backend uses?
Yeah, good question. So for when we're communicating with the server and we're using JSON, we use Logan Square. We use different library to basically parse it into these model objects, and then this is kind of more explicitly for storing in the database or like passing between activities. And then, so when we're communicating back with the server, we'll again use like Logan Square or something to parse it or package it back up into JSON. I think, yeah, is similarly to what I said earlier, not necessarily like the only way to do something like this, but we were really looking at kind of that narrow part of the storage, and then keeping everything else kind of the same, so we didn't do too much at once. Cool. If you have more questions, feel free to come talk to me. Definitely check out my computer's turned off, but check out the GitHub link for some more information, some more documentation. And I will definitely double check if the information about base serializers is on that, because if not, we should definitely add it. Thanks, everyone.